Automated YouTube channels are huge these days. In this video, I'll guide you through the steps to automate your YouTube channel using CrewAI. Our tutorial starts with a quick overview of the AI agent we'll be working on, followed by a step-by-step tutorial to build an AI agent that can automate YouTube video production using CrewAI. Don't worry, you won't need any prerequisites with CrewAI to follow along. I'll be explaining every piece of the code thoroughly and run the AI agent that we've built together. We'll analyze the system built with CrewAI, discussing how it operates and what makes it work. By the end of this video, I'll share my honest opinions on the pros and cons of using CrewAI for your automation needs. I'll also suggest on what it takes to step up to more advanced enterprise-level production. The method in this tutorial will help you automate around 70% of the video production work. That way, you can easily start an automated YouTube channel as a side project for an additional income stream. Without further ado, let's get started. Let's get into the structure of the AI agent that we're building today. When we talk about an AI agent, we're referring to a system with some level of autonomy that can accomplish clearly defined goals on behalf of the users. AI agents these days often involve several large language models or LLMs like ChatGPT or Claude collaborating with each other to attain the predefined goals. Our goal today is clear. We want to automate the video production process to make our life a lot easier. So, what would the AI agent for this job look like? First, we have a content researcher that collects the information needed for our video content and uses the data to craft a content outline with sections and key points for the video. This content outline will then be passed on to the AI Scriptwriter to create a script for the video. Then we pass the script to the AI planner to plan the scenes of our video. Now we have an AI researcher that does keyword research using some tools to look for well-performing YouTube videos on the desired keyword. Finally, we have an AI writer that generates a suitable title and description for our new YouTube video based on the script and the keyword search results. If you'd like to explore different AI agent structures from CrewAI, I highly recommend checking out the examples they offer in their GitHub repo. I'll put the link in the description below for you. Before proceeding to the project code, let me explain some basics of CrewAI and how it will help us create the AI agent we just described earlier. As the name suggests, the idea behind CrewAI is to build a crew that collaborates to achieve predefined goals. Think of it like assembling a team, where each member has a specific role and purpose. Within a crew, we have the specialized agents. Each agent is tailored for different tasks, working together to achieve our project goals. They can function in a sequential process, meaning the next agent relies on the output of the previous one. Alternatively, these agents can operate in a hierarchical setup where a manager agent delegates tasks to other agents within a lower hierarchy. Once we set up the structure, the agents execute tasks accordingly using the tools we provide if necessary. Now, one thing to note is that when I refer to agents here, I'm talking about the agent function from CrewAI. This is different from the AI agents that we talked about earlier. AI agents generally refers to the entire AI system that collaborates as a whole to meet the objectives defined by the users. When we get into CrewAI later in this video, I'll mention AI systems instead of AI agents to avoid confusion with the CrewAI agent function. If you'd like to learn more about CrewAI, I recommend their short course on deeplearning.ai. I'll put the course link in the description below. Alright, let's look at the project structure, which is pretty simple and intuitive. Within the project folder, we have main.py, which is a file that runs our main CrewAI setup. Next, we have the agents.py file, which defines all the agents at work within our AI system. Then we have the tasks.py file. Here we specify the tasks that our agents will execute. This is where we clarify what exactly each agent needs to do in order to achieve our goal. And last but not least, we have tools.py. This file contains all custom tools we defined for the agents to use if necessary. Don't worry if all this doesn't make sense to you right now. I completely understand that it might be overwhelming, especially if you're new to this. We'll go through every piece of the code, step by step, breaking it down into portions that are easy for you to understand. Let's talk about the setup and the packages you need for this project. Here are the packages we need in the requirements file to get started. The .env package to load your API keys and credentials into the environment, Pandas package to work with data frames, CrewAI with tools, AgentOps for monitoring to keep track of the performance of our AI agent, Google API Python client for YouTube data extraction. Install all packages under your virtual environment. Okay, let's move on to obtaining the required API keys. For the LLMs in this tutorial, we need an OpenAI API key. First, create an OpenAI account. Once you sign up, log in at platform.openai.com. New users get a $5 free credit, which expires in about 3 months. After that, navigate to the dashboard, then API Keys section, create a new secret key, and copy it into the .env file you created. And please, if you're using GitHub, never push your .env file credentials into the repository. You have to put .env in your gitignore file. Next, we get the AgentOps API key. Head over to agentops.ai and create your account. Then sign in at app.agentops.ai, go to API Keys, create a new project, and copy the API key into your .env file. And now for the YouTube Data API key. If you don't already have a Google Cloud platform, you'll need to create one at cloud.google.com. Upon sign up, you'll receive a $300 free credit. Create a new project, ensure that your console is set to this new project. Oh, and make sure to activate your free trial to a full account. There's a banner at the top of your page for that. Go to API and Services, enable the YouTube Data API. After that, navigate to Credentials, create credentials, and select API key. Finally, copy that into your .env file and name it accordingly. Alright, now that we have set up our project, we're ready to move on. Before we create the desired AI system, let me explain briefly on the concepts of agent and task in CrewAI. According to the CrewAI document, agents perform tasks, make decisions, and communicate with each other. Agents can have different roles and contribute to the overall goal of the entire crew. The tasks in CrewAI are specific assignments completed by agents. They provide all necessary details for agent execution. Tasks can also work collaboratively with multiple agents involved. Let's look at the agents.py file. We create a class named Video Creator Agents. Within this class, we provide the topic in which we prefer to create a video and the LLM that our agents will be using. Later in this tutorial, we'll create all the necessary CrewAI agents in this class. For a CrewAI agent, there are a few arguments we must define: the role that each agent will take on, the goal they're looking to achieve, and the backstory to provide more information around that role and goal. These three are required, and the remaining arguments are optional. We'll look further into some of the optional arguments when we focus on the specific agents later on. You can check out the CrewAI documentation that explains all the attributes. Now move on to the tasks.py file, create the class Video Creator Tasks. Within this class, we specify our topic of interest as well as the output directory where all the results will be stored. Later in this tutorial, we'll create all the necessary CrewAI tasks associated with each agent. For each task, we define a few arguments. We provide a detailed description that explains how exactly the corresponding agent should work. We specify which agent will execute the task and the expected output so that the agent knows what a successful completion stage looks like and when to stop. Even better if you provide a template for the output that gives more detailed stopping instruction to the agent. We also specify the context to provide a list of tasks in which their outputs will be fed as the context of this task. Finally, even though output file is optional, I always prefer to have the generated response saved in the file for easier viewing and debugging. It saves a lot of headaches later on. Now, with all that set up, we're ready to dive into the central elements of the AI system. We'll go through each element together, explaining every single part of the code. Let's kick things off with the first CrewAI agent for video content research. In the agents.py file, we create the content researcher agent within the class Video Creator Agents. The role of this agent is straightforward. That's the video content researcher. Then we have the main goal, which is to write a content outline based on its research on a given topic. We also need the backstory for this agent. This is where we set up the agent as an expert in research for video contents. Then give it a little bit more detail on collecting information that are valuable and interesting to create a YouTube video on the given topic. Ask the agent to put the collected information into key points for our content outline. We also make it clear that its output will be passed on to another agent in our crew. This helps the agent understand the sequential order of execution. Next, specify the LLM we're using, and we'll give it to this agent class later in the main.py file. We set verbosity to true. That will print out the execution process when we run it later on. We set allow delegation to false, since we don't need the agents to delegate tasks among themselves. Set max iteration to 5, so that the agent doesn't fall into a repeated loop when generating outputs. We'll explain more on this when analyzing the CrewAI run later in this video. Okay, let's move on to creating the task for our content researcher. This is where we give further details on how the agent should do its work. We provide a detailed description on the important things that should be included in its output and emphasize that other agents will be using the content it generated for their works. We elaborate on the key areas the content researcher should prioritize, things to consider when creating the content outline, and important sections to include. We also want the agent to incorporate SEO keywords and relevant sources for citation. When it comes to expected output, we want it to produce a video content plan that is up to our standard. Ask it to output in a specific format that we prefer. Explicitly state that the agent should strictly follow the template and no extra stuff should be generated. After all, LLMs can get quite chatty sometimes. Here we give a clear template that the agent should follow within the triple backticks when generating its response for the content outline. Give it some exact examples on how the output should look like. For instance, here we write section 1, followed by the section name. Key point number 1 should be here, followed by point number 2, and point number 3. Same goes for section 2, the section name, first key point for the section, then the second point, third key point, and so on. You can stop the example of sections here, but I usually give it another one more just to be sure. The key points for this section, and the remaining sections. We also want the SEO keywords to be included, and the relevant source citation. Next, we have the agent that is responsible for this task. It will be provided to the task later in the main.py file. Finally, save the generated content outline in an output file at the desired path. We're done with the content researcher part. Now let's get to the second element, which is script writing. This agent is dedicated to writing scripts for our video. We set the role as video scriptwriter, and the goal is to write a script for our YouTube video in the desired topic. For the backstory, we tell the agent that it's an expert in script writing and be explicit that we want a video script that is interesting enough to retain viewers' attention. We specify that it should perform tasks based on the content outline provided by the previous agent, which is the content researcher. The agent should also annotate clearly if it is providing its own opinion on the topic. Tell the scriptwriting agent that its output will be fed to the next agent in our workflow. Put the LLM argument here, and the exact LLM will be given to the agent later in the main.py file. Set verbosity to true for printouts. Allow delegation to false, since we don't need to delegate tasks to other agents. Again, set max iteration to 5. Now let's create the task associated with this agent. In the description, we emphasize that other agents will be using the script that it generates for their work. Then, we give a detailed explanation on how the agent should do script writing. We should use the outline generated by the content researcher agent to write a script on the given topic. The script should be written in a specific way and tone that aligns with our needs. We also require the agent to include data sources for any factual statements made throughout the scripts to build up credibility and trust with our audience. The scriptwriter should also come up with good section titles to ensure the script flows well and is easy to follow. Additionally, we specify the desired structure for the video script. We also state the importance of producing a script that is free of errors. For the expected output, we want it to produce a video script that is up to our standard. As usual, the expected output argument will have a template for the agent to follow. We ask it to output in a specific format that we prefer. Tell the agent to strictly follow the template. And no extra stuff should be generated. We give a clear template that the agent should follow within the triple backticks when generating its response for the video script. Give it some examples on how the output should look. Here we write section 1, followed by the section name. Sentence number 1 of the video should be here, followed by sentence 2, and sentence 3. Same goes for section 2. We have the section name, first sentence of this video section, then the second sentence, third sentence, and so on. Again, you can stop the example of sections here, but I usually give it another one more just to be sure. Put the sentence for section 3, and the remaining sections. We need an argument for the agent, and we'll specify which agent is associated with this task later in the main.py file. We also need an argument for the context to provide a list of tasks in which their outputs will be fed as the context of this task. The context will be specified later in the main.py file. Finally, save the generated video script in an output file at the desired path. Alright, let's move on to the next piece in the puzzle. The third element in this AI system, scene planning. We set the role as video scene planner, and the goal is to focus on designing the scenes for our video on the given topic. For the backstory, we set the LLM to be an expert in scene planning and be explicit that we want a scene plan that is interesting enough to retain viewers' attention. Just like before, we specify to this agent that it should perform tasks based on the video script provided by the Scriptwriter agent. The scene planning agent develops a detailed shooting plan for each scene in the script. This ensures we have clear guidelines for both shooting and post-production. Place the LLM argument here, and the exact LLM will be given to the agent later in the main.py file. Set verbosity to true for printouts. Allow delegation to false since we don't need to delegate tasks to other agents. Again, set max iteration to 5. Now let's create the task for the scene planning agent. In the description, we ask the agent to develop a detailed plan for each sentence in the script so that we have clear guidelines for both shooting and post-production. Create scenes in the desired style that can retain audience. And make good use of various effects. This plan must include essential elements like the type of graphics, sound, and video effects to be used in each scene. Make sure that the flow between scenes are natural. For the expected output, we want the agent to produce a scene plan that is up to our production standard. As usual, the expected output argument will have a template for the agent to follow. To keep everything structured, the output from this task should be formatted as a CSV file with the following columns: the scene number, which helps us keep track of the video parts, the audio column that specifies the sentence of the scene that is from the video script generated by the Scriptwriter agent, and the visual column that explains how the scene should look and sound, providing clear instructions for the production team and editors. We give a clear CSV template that the agent should follow within the triple backticks when generating its response for the scene plan. Tell the agent to strictly follow the template. And no additional things should be included. The desired CSV output columns are scene number, audio, and visual. Give it some examples on the rows of the scene plan CSV file, and the remaining rows for all the scenes of our video. We need an argument for the agent associated with this task, which will be specified later in the main.py file. We also need an argument for the context to provide a list of tasks in which their outputs will be fed as the context of this task. Again, the context will be specified later in the main.py file. Let's save the generated video scene plan in an output CSV at the desired path. Next up, we introduce our keyword research agent. The role is of course video keyword researcher, and the goal is to do a YouTube keyword search on the desired topic using a tool that we'll define later. It'll use the YouTube Data API to gather details about the top 20 ranking videos in a YouTube search for the specified topic keyword. This agent is important in optimizing our content for searchability on YouTube. For the backstory, we define the agent to be an expert in keyword research, and instruct the agent to use the custom tool we'll provide later to identify the top 20 ranking YouTube videos on the desired keyword topic search. We also specify that this extracted information will be used by another agent in the workflow. Put the LLM argument here, and we specify the LLM to the agent later in the main.py file. Set verbosity to true for printouts, allow delegation to false, set max iteration to 5, and provide the custom tool over here to do keyword search on YouTube. Now we define this custom tool called YouTube Keyword Search Tool in the tools.py file. Let's take a quick look to tools.py and see how we should create this custom CrewAI tool. Import all the necessary packages and define the class YouTube Keyword Search Tool. Based on the CrewAI documentation, the format we need is pretty clear. We need to define our tool as a class with name, description, and an underscore run function. Name the tool, give it a clear title that conveys its purpose. The description of the tool is very important. Make sure it's written in a way that the agent can easily understand how and when to use this tool. And we explain the arguments for the underscore run function for the tool. Query refers to the keyword we'll be searching for using the YouTube Data API, which is the topic we give to our agents. Max results is the number of video results we'd like the API to return. Before we create the underscore run function, let's go to the YouTube Data API document to learn how to use this API. Since we're doing a keyword search, go to Search, then List, look at List by Keyword, open up the API Explorer. This example is using max results 25, and query queue is surfing. Untick Open Authorization since we don't need it for keyword search. Execute. Go to the Python tab and look at the code to build the API connection, create the API request, and execute it. Now let's get back to our tools.py file and create the underscore run function. Create the connection to the API client by providing the YouTube API key. Then create the search request by following the example code in the API document. Execute the request, and get the desired items from the search response. We extract the details we need, such as the rank and video title. We also need the video ID to make another API call for statistics related to each video. Append the video search result into a list of lists. Before putting it into a pandas data frame. Let's make another API call to get information such as the number of comments, likes, and views for each video. Create the search request, execute it, and get the desired items from the search response. We extract the details on the number of comments, likes, and views for each video. Append the video search result into a list of lists. And put it into a pandas data frame. Now we merge the two pandas data frames together and convert the merged data frame into a CSV format, which makes it easy for the agent to read and process. Great! We've done all the heavy lifting in creating our custom tool. Now let's get back to the tasks.py file to create keyword search task. Here we write a description that clearly mentions the arguments like 20 max results on the topic keyword that the agent should use to run the tool we've created. As usual, the expected output argument will have a template for the agent to follow. The output from this task should be formatted as a CSV file with the following columns: rank for the video ranking of the YouTube search result, video ID, the uniquely identified ID of each YouTube video, video title, which is the title of each YouTube video, comment count, that shows the number of comments for each YouTube video, like count, showing the number of likes that each video obtained, view count, which is the number of views the video has acquired since published. We give a clear CSV template that the agent should follow within the triple backticks when generating its response for the keyword research. Tell the agent to strictly follow the template and no additional things should be included. The desired CSV output columns are rank, video ID, video title, comment count, like count, and view count. Give it some examples on the rows of the top ranking video CSV file, and the remaining rows for the rest of the ranking videos. Now you might be wondering, why are we still explicitly showing how the CSV columns should look like in the expected output, even though our tool is already generating the desired format? Here's why. If you don't articulate the CSV format explicitly in the expected output, the agent may go into a lengthy loop of repetitions in an attempt to arrive at the expected output, since it might be thinking that the output state isn't achieved yet. When this happens, it triggers repeated thoughts, actions, and observations, which quickly takes up your budget with unnecessary LLM calls. So it's better to be clear up front to avoid this. We'll explain more on the thought, action, and observation process later when we analyze the CrewAI run. We need an argument for the agent associated with this task, which will be specified later in the main.py file. We also need an argument for the context to provide a list of tasks in which their outputs will be fed as the context of this task. Again, the context will be specified later in the main.py file. We save the top ranking videos in an output CSV file at the desired path. Let's introduce element number 5, Title and Description Generator, the final piece of our puzzle. This is where we create an agent to generate engaging titles and descriptions for our new video. Put video title and description writer as the role, and the goal is to create titles and descriptions for a new YouTube video on the desired topic. For the backstory, we define the agent to be an expert in creating video titles and descriptions. We let the agent know that it should generate titles and descriptions based on two important pieces of information: the video script provided by the Scriptwriter agent and the high-ranking video details gathered by the keyword research agent. Why is this important? Because we want our new video to rank high in YouTube searches. We also want the title and description to be able to attract high click-through rate. These are key factors in growing your audience and channel subscription. We have the LLM argument here, and we'll specify the LLM to the agent later in the main.py file. Set verbosity to true for printouts. Allow delegation to false, since we don't need to delegate tasks to other agents, and set max iteration to 5. Let's move to the tasks.py file for the title description writer task. We provide a task flow that the agent should follow when generating video titles and descriptions. First, we emphasize on using the video script and keyword search result to generate 5 catchy titles and descriptions for our new video on the desired topic. This variety gives us option to choose from and select the best fit for our content. We specify the character limit of 100 for the video title and ask the agent to generate titles with high click-through rate. Then for each video title, generate a description that can make our video rank high in the relevant YouTube keyword search. Specify the character limit of 5,000 for the video description to keep our output concise and within the standard expected by the YouTube platform. We ask the agent to generate titles and descriptions in a way that maximizes the potential for our video to rank high in keyword searches. We emphasize on using the video script provided by the Scriptwriter agent to ensure that the generated titles and descriptions are well tailored for our video. For the expected output, we give a clear template that the agent should follow within the triple backticks when generating its response for the titles and descriptions. We ask it to output in a specific format that we prefer. Tell the agent to strictly follow the template. And no extra stuff should be generated. Give it some examples on how the output should look like. Here we write the first generated title, followed by its corresponding description, then the second generated title, and the corresponding description, third generated title with description, and the remaining titles and descriptions. We need an argument for the agent and we'll specify which agent is associated with this task later in the main.py file. We also need an argument for the context to provide a list of tasks in which their outputs will be fed as the context of this task. The context will be specified later in the main.py file. Finally, save the generated titles and descriptions in an output file at the desired path. Now it's time to put everything together in the main.py file. We begin by loading the .env file to access our keys and credentials. Next, we initialize AgentOps for monitoring. This tool will help us analyze our agent's performance later. Then we create an output folder for the run. This is where all the results from our agents will be stored. Now let's initialize our LLM. In this project, we're using GPT-4o Mini to generate responses, and we provide the OpenAI API key here. Next up, define all the agents that we previously established. Provide the agent class with the selected topic and the GPT-4o Mini LLM. Then call the individual agents: Content Researcher, Scriptwriter, Scene Planner, Keyword Researcher, and the title description writer. Define all the tasks that we created. Provide the task class with the selected topic and set the output directory as the run folder we created. Call the individual tasks for Content Researcher, Scriptwriter, Scene Planner, Keyword Researcher, and Title Description Writer. Notice how we specify the task outputs that should be used as the context for each task. The context dependency is similar to our AI system workflow. We feed the content research task output as the context of the script writing task, the script writing task output as the context of the scene planning task. The keyword research task is an exception. It actually doesn't need any context, but we feed something relevant to it anyway, because if we leave the context empty, CrewAI will automatically assign the previous task output as its context. And we don't really need the scene plans to do keyword research, isn't it? Finally, we feed the outputs from both script writing and keyword research tasks as the context of the title and description writing task. Now we define the crew itself. Since our process is sequential, we should feed the agent and task lists in a similar sequential order to avoid confusion, especially if you're not specifying the context. Set the process as sequential. Ask the crew to save the runs log file at the desired path, and set verbosity to true. And off you go! The crew is ready to kick off. But don't forget to end the AgentOps session to make sure everything concludes properly. We demonstrate our crew run on the topic Artificial Intelligence in Marketing. Feel free to change it to any topic you like. Wow, what a long journey! If you've made it all the way here, you should be incredibly proud of yourself. Let's run the code. It'll take some time for the run to complete. We'll get back once it's done. Okay, we're back. Now let's take a look at the results from the code run. At first glance, it's a bit daunting with such a long printout, but don't worry, we'll look at it together. Let's head over to the AgentOps dashboard and analyze our CrewAI run from there. You can access the dashboard through the session link that was provided to you during the run. Once you're in the dashboard, you'll be able to see all the session data. You'll find information such as the total cost of LLM calls, the tokens used, and the overall runtime. You can also see the exact prompts that CrewAI sent to the LLMs. One of the coolest features is to view the session replay. The session begins with a call to the content researcher agent, followed by the scriptwriter, the scene planner, the keyword researcher, and then the title description generator. Let's dive a bit deeper into how CrewAI prompts the LLMs. Take the scriptwriter for example. It starts by clearly stating the role you specified for the agent. Then it gives the backstory and goal that you provided to the agent. Now what happens here is that CrewAI has a thought, action, observation process. This is telling the LLM that when it declares, "I now can give a great answer," then it has arrived at the best final answer and is ready to stop. Otherwise, the thought, action, observation process will be repeated. Now when it comes to the format, this is where your task specifics come into play. If you recall on the Scriptwriter task we created, this is the task description we wrote. This is the expected output with the template we provided in the Scriptwriter task. We also specified in the main.py file that this scriptwriting agent should use the output from the content researcher as its context. Then the corresponding LLM returns a response. Remember that you can also view the final outputs in the Run folder. Based on the result, our video automation goal looks pretty straightforward for the AI system, since it got to the final answer without many repeated thoughts, actions, and observations. It's all coming together nicely. Let's dive into the pros and cons of using CrewAI, in particular whether it's ready for enterprise-level production. One of the major advantages of CrewAI is that it provides a very good starting point for those looking to learn how to build their own AI agents. The learning curve is not steep, you don't need any extensive knowledge of LLMs, just knowing a little bit of Python will do. This makes it an excellent choice for beginners on AI agents to learn prompting skills with CrewAI and understand how they structure and interact with their LLMs within an AI system. However, there are some challenges to consider. If you're looking to further customize the workflow of your crew, like controlling the exact prompts sent to the underlying LLMs, it may become difficult. For those interested in customizing prompts, I recommend checking on their documentation at the link below. I wonder why these important details are not included in the how-to guide section on the side panel though. Currently, CrewAI supports crew setup in either sequential or hierarchical forms only. Enterprise-level solutions often involve multi-level hierarchical setups, which is significantly more complex. If your CrewAI agent setup starts getting too complicated, well, good luck with that. Even with a single hierarchical setup, it tends to use more tokens than necessary compared to the sequential setup. This inefficiency is due to the manager agent that uses additional LLM calls to delegate tasks effectively. What's even worse is when the manager LLM struggles to assign tasks properly. It could end up making repeated LLM calls until it finally figures it out. That's definitely not encouraged for enterprise-level production. If you're thinking of deploying an AI agent in a business context, you will need a concrete cost management plan in place, plus a reliable system guaranteeing quality output with a low fail rate, ideally within 1 to 5%. For those willing to experiment, you can try out the hierarchical setup in main.py by changing the process to hierarchical and uncommenting the annotated code. So, whether CrewAI is good for you, it depends on your needs. It has some advantages, especially for beginners, but scaling it to complex operations may require a little bit more work with careful considerations. If you find this video helpful and want to learn more about AI agents or artificial intelligence in general, I invite you to book a 50-minute consultation session with me via the link below in the description. I'll be more than happy to answer your questions and direct you to the resources you need to kickstart your own AI journey. If you find this video useful, please take a moment to like and subscribe to this channel. Thank you for joining me. I look forward to seeing you in the next video. Take care and see you then.